going to do today is already I have introduced you with multi-agent systems in the last class, but we are going to design more robust multi-agent systems. But today is more of a theoretical class. Practical we will do in our next sessions because it's very important to understand how these large language models work and how can we generate different parts of content with different types of large language models. So it's very important to understand how the brain of the agent works. So it's the today's session is all about that. And in our next session, we will again go back to practicals and designing our own agent system and then deploying it on the web. So let's start with today's class. I have made these slides for you. I will just share my screen so that you can see the slides. All right, so today's class is about large language models and understanding the brain of agents. So for the last two class, we have been talking about like how to create our agents, and we have been talking about the large language model, which is the part or the brain of the agent, right? So this large language model is what we were using for the agent to even generate text or make a decision. Like in our last class, we made a decision using a large language model that whether the sentiment of the given review was positive, negative, or neutral. And we were making these autonomous agents by using these large language model, right? So today, let's understand what are these large language model and how these large language models work. By understanding this, we will also understand how can we use different types of large language models and what are their limitations, what are their advantages. So what we learned today is how AI generates text, first of all, like text generation. I will talk particularly about text generation because that's the most common thing that AI generates, like the text that we require. It can be or it can be something like an article, it can be an email, it can be a classification, it can be any text that you want, right? And then we dive deep into large language model, what are they, and then transformer architecture on which the large language models are based on. Then we will go to fine tuning of models. How can we fine tune our own models and how why it is very important. Then we will go into how AI generates images, which is image generation. We will talk about like GANs, which is generative adversarial networks, how they work, diffusion models, how diffusion models work, and stable diffusion model, which is the state of the art. So this is more of like a intuition class where you will understand how the large language model generates what it is generating and the theory and the concepts behind that, so that we know what is our brain comprised of, and if we want to create our own brain, how can we create that, right? So rules of the class is I will use English. I will have to use English language because all there are students from all over the country as well as from other countries studying in the GTU, and that's why I will be able to cater to everyone by this. Difficulty of this class is medium to hard level of tech understanding. Some of you might feel it like it's easy to understand. Some of you might feel it challenging. But if you feel it challenging, then ask questions. Just like our last two master classes, if you read, you will learn. If you hear and visualize, you will learn more. But if you participate, you learn the most. So ask questions in the chat, reply to the questions that I'm asking, and that way it will be a two-way communication, not just one way. And unless you have a memory chip installed in your brain, please take notes. So grab a notebook, grab a pen so that you are ready with today's masterclass. It's a non-code, non-developing, no practical masterclass, just a theory masterclass. But I hope that you will be interacting with me on the chatbot so that we are learning more together. So the class has been divided into two parts. For the first 1 hour, I'll be talking about text generation, how it is happening, and how can we generate our own text. The second part of this masterclass is about image generation and how image is being generated. So we are going to see the concepts behind the large language model or the brain of our agent, and we will just see how in the future. Let's say if we want to design our own proprietary agent, how can we do that? And not being uh, not being just relying on ChatGPT and Gemini as the models, right? All right. So how text is being generated by ChatGPT? We will start with that. And so every large language model that we see, let's say I'm talking about ChatGPT, but I will talk about large language models in there. Every large language model that generates something generates this by predicting the next word in the sequence. So we'll see in a while. Let me just go to a tab and I go to any large language model, let's say ChatGPT, and I opened chatgpt.com, let's say. And if I ask a question to this, let me ask, what is the capital of India? Okay. And if I ask this question, you will see how the behavior of this large language model is. So if you just type in, it says the capital of India is New Delhi, right? So it typed it very fast. That's why I could not get the gist of it. Just write an article about India. So if you see, if it is generating something, it is just generating word by word, right? So it's not giving all the thing at once. It is just generating it word by word. So what it is doing is not some fancy animation that OpenAI has put. It is actually how large language model works. So it just predicts the next and the next word in this sequence. So when I typed what is the capital of India, it just predicted the next word, the. Okay, and after the, it predicted the next word which is there. So this is how a large language model works. And we will see how this prediction happens and how can we make our own large language model predict something. So any large language model, let's say ChatGPT as example, generates this text by predicting the next word in the sequence. And that's the beauty of large language models. It's kind of like not the brain, not how our brain works, but still mimicking human intelligence by just predicting, by just probability, right? Using some mathematical concepts, like keeping words as vectors, and then predicting the next word in the sequence. For understanding how this prediction happens and what is large language model, let's go back to where we have seen such type of behavior, right? So before ChatGPT, before 2018 that ChatGPT was released, 2017 it was released, the first version of that, and then 2018 and 2023 was when ChatGPT launched its the most powerful model, which made ChatGPT really popular and AI really popular in a general sense. Um, but we have been doing this for the last 20-25 years. In 1990s, when I was studying artificial intelligence, we used to study about large language models and language modeling. I did my bachelor's in 2014, by the way. 2017 was when the most advanced architecture uh, came into existence. So when we were learning large language models and when we were learning artificial intelligence, we were learning more about language modeling. So in Google, if you type something, let's say if you type I want to, then it generates or it predicts what you want to type, right? It says that, okay, maybe you want to search, I want to play games. Maybe you want to search, I want to break free. I want to learn. I want to sell my phone. Okay, and if you in your phones also you have this auto type or predict system, right? So if you type please send me an, it will give you these options like email, update, updated, right? So how is it predicting this? How is it just completing your sentence, right? Is what language modeling is about. And this language modeling, when we used to do it in past, we used to do it with search and count method. So Google searches how many times after I want to, some word has come. Let's say play is a word that comes after I want to. Then how many times people have searched about I want to play games? And they will also count how many times you have searched that in past. And based on some probabilistic just like Netflix's recommender systems, it predicts the next word that is there in the system. So if I type I want to, then it predicts cook on the, it counts how many times I might have searched I want to cook food. And it gives that the first priority in the search. So it says that I want to cook, cook can be the other word. And then after cook, it can be food based on um, the number of times I have searched that, right? And if I want to play is the next word, then after play games and music, depending on how many times I have searched games and depending on how many times I have searched music. So I want to play music. If I have searched more, I want to play games, then it will show that in the priority, and it will predict that, okay, the next word that you are going to type can be play or game, right? And this model was, however, it was powerful, but it was very crude. It did not contain the context of what you want to type, but it still was very good. So I remember my earlier days when Google had this I am feeling lucky feature, right? So if you type something and you click on I am feeling lucky, it will always open the right side. Not always, but almost always. It learns from your behavior, how many times, how many people in the world are typing the similar thing and landing up to the similar type of websites. So this is the language modeling that we are talking about, which was generating some text in response to what I was typing. And the bigger version of this language modeling is what we call as large language models. And that is what the brain of all these generative AI tools that we have in the market. So ChatGPT, Gemini, then there are many Grok, then whatever large language model that you can think about, Anthropic's Claude is there. All of them, they use large language models to generate the text. All right. So they are not some fancy hi-fi tech that we have inherited from some alien civilization. It's kind of like just basic prediction of the next word in the sequence. So what are these large language models, and how do they form a brain of the computer? How can we train our own large language model? What they contain of? How can we build one is what this session is more about. So these large language models are the brain of all the generative AI tools that are there in the market today. That's what we have established. So now, so what are these large language models in reality? Okay, so let's understand the generation of text by ChatGPT or any large language model by this simple example. Okay, so let's say if I ask this question, what is the tallest building in the world, to a large language model? Okay, so how does it generate the output? Is what how does it generate the output? Let's see that. Okay, so in your chat box, can you quickly tell me what can be the next token in the sequence to this? If I ask what is the tallest building in the world, what can be the next word that is there in the output? So Pranjal is saying the is the next word. Jill is saying Dubai. Dubai is not the tallest building in the world. Tallest building in the world is Burj Khalifa actually. But yeah, so a lot of people are saying the or tallest. Burj Khalifa, someone is saying the is the next word, right? Yeah, this is how our brain also works, right? When we speak any language, so let's say that I'm speaking this English language right now, and what I'm doing is just speaking or just saying the next word, right? And by just saying the next word in this sequence, I am speaking the whole text. And this gist or this intuition is what we use in the large language models. All right, so when I send this, what is the tallest building in the world? So first step of what all these large language models do is they tokenize this. Okay, so computers don't understand sentences, right? Computers don't even understand words. They only understand numbers, right? So in order to make the computer understand these words and also to make uh, the computer understand the context between these words, like tallest building and word, the context between these three words, and generate the next token, what they need to do is they need to first chunk this sentence. Okay, and they chunk this sentence into something called tokens, and these tokens can be even words, they can be sentences, also they can be symbols also, depending on what is the tokenizer that you are using. Okay, so this chat gpt, they use this word tokenizer, and also characters are also being tokenized. And there is a whole process of how this tokenizer is formed. Actually, it crawls through all the text that is there in the world, and it finds a similarity between two words, and they do the byte pair encoding. And then according to this byte pair encoding, they form these pairs of words that occur together, and then they separate these words as tokens, and they increase their dictionary similarly. It's kind of like a very difficult concept to understand mathematically, but if I talk about like in simple terms, it is just identifying how many types of words that can be there in the English language, and then dividing them in the part of tokens. So if I ask this to ChatGPT and I go to this link also, like tokenizer, if I or really want to see how ChatGPT is tokenizing, then they have given their tokenizer. And if I ask any question to this tokenizer, let's say that what is the capital of India, and it will just tokenize this into these tokens, right? I didn't write what, I wrote what. Okay. So I see that it is divided into 7 tokens. What is the capital of India? And this question mark is also a token, right? So these tokens, all these tokens, what is the tallest building in the world? They go to this large language model, whatever large language model is there. Let's say ChatGPT is the large language model that we are using right now, and it just generates the next or predicts the next token in the sentence. So it predicts this next token, which is the, right? And this the is now added to the input of this large language model. And after adding this to the input of this large language model, it predicts the next consequent token in the sequence. So I generated what is the tallest building in the world. It generated me the first token, which is the, and after adding this to the input, it predicts the next token in the sentence, which is tallest. And then this tallest will be added to the input, and then next token will be predicted, which is building. And this building will be added to the input, and the next token will be predicted, which is in. And this in will be added to the input, and the next token will be predicted, which is the. And then the will be added to the input, and then world, and then is, and then bur first, bur, and then j as an independent token, and khal khal as a token, and then ifa as a token. So it depends on, because Burj Khalifa is not a in the dictionary, there are not many instances of Burj Khalifa. That's why it is not taking it as a byte pair encoding of the words. So BUR is still a word that is seen more. That's why this tokenization is being done as BUR as together, and J as separate, and then KHAL as together, and IFA as separate. So by generating this, after generating everything, it generates this end of sequence token, which tells ChatGPT that the answer has been completed. Right. And by generating and by inputting what is the tallest building in the world, it generates this as the answer. The tallest building in the world is Burj Khalifa, and this end of sequence is equal to the full stop that is there in our English language. So just by predicting the next word in the token, the next token in the sentence, it is writing all these answers, and we could see that by seeing our ChatGPT in action also, right? When we are asking it some question, it was just generating word by word. So how is it doing that? Is what we need to think about, right? As scientists, as engineers, as people who are designing something, the curiosity part of it is not how it is doing. The curiosity part is how, not why, what it is doing. The curiosity part is how it is doing, right? So how does it predict? We say that, okay, it is just predicting the next word in the sequence. And just by predicting the next word in the sequence, it acts like it is really, really smart. How does it predict is what we will tackle next. All right. So it predicts all these all these tokens and all these words by these large language models. We have already told about it, but what is inside these large language models and how can we make one is what we will now talk about. So basically, large language models are nothing but two files that we run on GPUs or cloud. One file is a parameter file, which we obtain by compressing all the text that is there in the internet, uh, basically taking the gist of all that text. But that compression that we are doing of all these text that is there in the internet is not a lossless compression. It is a lossy compression. Okay. So we are not basically, when you compress some file in a zip format or another compression format, it's a lossless compression, right? Whatever you input, whatever you compress, it will always come out the same way. What we are doing with this parameter file is basically we are compressing all the text, all the word written in English language into these parameters, which is kind of like a gist of the language. And then we run these parameters on this run.c file, which uses some logic to take the input from a user, go to these parameters, and get the next token that is there in the sequence. And by doing these, getting these parameters and running this run.c file, we can talk to this language model in a natural language. How can we obtain the parameters is what we need to think more about. And just all of this system, like these parameters, this run.file, C file, that run on cloud or GPUs. Okay, so we have these GPUs which can process parallelly a lot of data. And that's why NVIDIA is one of the largest company in the world right now, because they make GPUs and they have kind of like a monopoly over it. And by obtaining these parameter file, we will keep this on the internet, on the cloud, and we will run this run.c file on. It can be in any language. I am taking here as run.c, but it can be in Python and any language that matters. So it interacts, it takes the user input, it goes to this, it goes from this, it feeds these user input into this parameter file, and then these parameters, they adjust itself, and then they predict some next token in the sequence. So what are these parameters, right? And let me just explain how to get that and what are these parameters in reality. So if you have seen this figure, this is kind of like a neural network figure, right? So we have this neural network with us. And this is just a small neural network that I'm showing right now. So it has just 3 nodes as the input layer. It has these 8 nodes as the hidden layer. And they map with these 8 nodes. And then there is output layer. This is how human brain, this is kind of like a simulation of human brain, how human brain works. So we have these billions and billions of neurons in our brain, and which are connected to each other. So if I touch any hot object, it just goes into my body, it signals my brain, another neuron, one neuron signals another neuron, and in reality all these 30,000 neurons, they get fired. And based on whatever I have learned in my past, whether to hold that hot object or to throw it, depending on what my experiences in the past were, or how valuable that hot object is, then I will make a decision, right? So this neural network that I have is what these parameters are. So these circles that you are seeing are called nodes, and these lines that you are seeing are called branches. And while we train this neural network on words, we feed this input layer with words as vectors, and doing some mathematical calculation, these weights, these nodes, they hold some value in them. And based on this value, they predict the next word that is there in the sequence. So not going deep into mathematics and all part of it, where we will talk about like objective function, backpropagation, and all these things. I am just going to explain in very simple language what are these parameters. Let's say that they are some values. Okay, so they are some values which these nodes they hold, and based on these values, they predict what is the next word that is there in the sequence. So if you see this small toy neural network, there are 3 nodes in here, there are 8 nodes in here. So the total number of parameters will be 3 into 8, 24, these branches that are there. And this 4 I add as a bias, which I adjust in order to adjust my output. Okay, so in total here, the parameters are 122. So my idea of introducing you to the parameters is that basically we are obtaining some values in a neural network for all the text that is there on the internet, some values on this neural network that will be kind of like a gist of the language, which has all the information that is there written on the internet. And when you send in a data or a input or ask it a question, by having all the knowledge about that language, it generates or it predicts the next word in the sequence, right? So if you see here, this toy neural network has 122 parameters. ChatGPT has 175 million parameters. There are now large language model with billion parameters also, right? So you can just see the scale of this neural network that they have. All right. So if I want to create my own large language model, what are the steps or what are the things that I will require? Like just like ChatGPT, right? So first of all, you already know we need lots and lots of data, right? So whatever data is there in the internet, we scrap that by these tools called web scrapers. We go to each website, take the data from there. We have Wikipedia, we have social media, we have GitHub, we have Quora, we have Reddit, we have all these blogs, posts, and all. So we go to all these websites, take in a lot of data from there, and we store that in a file which we call as corpus. And after storing that in a file, which is corpus, we use some architecture like a transformer architecture, which is very good in understanding the language to train this architecture on whatever data that we have, right? So we get a lot of data and we use an architecture that trains on this data. We host this architecture on some GPUs, which we buy with, of course, a lot of dollars. ChatGPT took 100 million in funding from Microsoft or OpenAI, the company, and these GPUs they ran for. So this is a kind of like a card of 60,000 GPUs. They ran for like 3 months continuously in order to train all of the text that is there in the world on these transform architecture to predict the next word in the sequence. And then we do fine tuning, which is basically how we can make our language models more better in any field that we want it to be. So if you want to create your own large language model, you need these four things. You need a lot of data. You need a transform architecture, which is one of the best architecture right now to train large language models or language models. And then you pre-train it on GPUs and a cluster of them. And then you fine tune them on your own proper data or by human reinforcement learning and other methods. So the recipe of making this large language model is first step is to make a large corpus. So you take a web crawler, you crawl all the words text that is there in the world, and then you step two is to train the language model on these GPUs and obtain the parameters that you need for predicting the next word in the sequence, and then you fine tune the model. Okay, so first step is to make a large corpus. Second step is to train the language model on these neural network to obtain the parameters. And final step is to fine tune the model so that it behaves the way that you want it to behave. All right, so let's explore all these three steps one by one and see how we can build our own large language model and how ChatGPT and Gemini, they have built their own models. So first step is to build a corpus, right? So we need to have a data in which we will train this neural network in. So we say that there is a brain which is empty right now, which is neural network, right? And we need to have a data in which we train this empty brain to understand the language. So what we will do is we will build a corpus. We use web crawlers, and they search all these websites like Wikipedia, Quora, social media, GitHub, Pinterest, articles, and blogs, and it searches them and saves them so it makes a database of whatever data is there in the world. And before we move further to step two, I have some questions also so that it doesn't become like a one-way communication system. So step one is to build a corpus. Step two is to train a language model. But before I go to train a language model, let me check what is the understanding that you are having right now. So a quick question: how does ChatGPT generate text? If you have the answer as A, it predicts paragraph by paragraph. You say in the chat box as A. If you think that it's B, it predicts the next and the next word only in the sequence, and you say B. C, if it predicts the whole next sentence and display it. D, if you generate the whole document at the same time. So just let me know so that we are at the same page. And also, if you have any questions in between. A lot of people are saying B, which is the correct answer. That means that you are listening with focus in this class. Thank you so much for replying. I will also check the messages for any questions in between if there are any. Channel is asking, sir, it can predict only one word or many word and then select the best word. Yeah, so the idea is to map the next word with all the words that are there in the English dictionary. All right, so this will become clear when I explain the transform architecture in the next slides, how it actually generates this text. Okay, so it predicts one word, but it maps the probability of this word to all the words that are there in the English language. So it predicts a range of words, and from there it chooses the best word that is there that can come. So basic idea is that it predicts the one word, but uh, Om is asking in which form parameters are stored, like in JSON form or any. So it's not stored in some JSON form or something like that. It's stored as some values. So it can be. How these neural networks store these parameters? It's kind of like a black box system which nobody knows how these parameters are obtained and how these parameters are being stored. And that's the beauty of these large language model, that a lot of it, how it is happening and how it is adjusting these parameters and weights and biases, is what we don't know about. And but it works, and we know that it works, and that's why we um, uh, that's why we are able to do all these amazing things in this. Ansh says DeepSeek said not to use as much GPUs like other private LLMs. How? Okay, so Ansh is asking DeepSeek, how DeepSeek achieved that. So how DeepSeek did was DeepSeek used reinforcement learning to train its large language model. So there are like two base ways to create a large language model. One is by scrapping all the word that is there in there, and then you train these neural networks on all the text that is there in the world, and then predict the next sequence. But what it doesn't do is it doesn't use reinforcement learning. So let's say that you have a big large language model and you want to create another one, and you are asking this smaller language model to predict what can be the next word in the sequence, and you use that bigger large language model to train that smaller large language model in order to say that, okay, the next sequence that you are kind of like generating, is it right or not? And by training this with reinforcement learning, by saying that, okay, whatever you are generating next is right, because I know that is right, and then adjust its weights and biases to understand, to generate better. So ChatGPT doesn't reason with itself. It says that whatever I'm generating next is what I have learned from all of the text that is there in the English language. And by making connection between that text, reinforcement learning, what it does with DeepSeek is that it reasons at every step. It says, okay, I am going to generate this next token. Will it be the right token that I want to generate? All right. And just by using that reinforcement learning concept, DeepSeek could achieve what ChatGPT could not, with as less GPUs as possible. All right, interesting questions. Sehul is asking, how does it do for image and audio? I will explain that in my next part when we will talk about like image generation. Anjali is asking, what are weights and bias? So you can just take that as some numerical value that is stored in a node of a large length of a big graph. Let's say, what do you call that? Artificial neural network. That is some mathematical value that is stored as these weights and biases. So basically, weights are the values that these nodes store, and bias is a term that we introduce to adjust my neural network to behave properly. So this is kind of like a margin that I have taken in order to adjust my answer to the right one. All right, thank you so much for your wonderful questions and wonderful answers. We have less time in our hand. That's why I could not attend all of your questions. But if you have the questions with you, let me know in the chat box. All right, so let's go to step 2, which is training the model. Okay, so we say that, okay, these parameters are in which my ChatGPT will store all this data in. How will I obtain these parameters, right? So how will I train this language model is what we need to think about then. So it's very easy to train a model. So we take a neural network and all right, so I will just go back to this. So we need to we need to train this model or to obtain these parameters, which are some values that these nodes will store. Okay, so these nodes are storing some mathematical value in it based on many formulas that there are there, and I need to obtain these values. So how can I obtain these values, right? Is the question, or is the answer. How can I train this big artificial neural network to predict the next word in the sequence? What I do is I during the training part. Okay, so during the training part, I have all this text that is there in the English language, right? I have a text about Taj Mahal, right? So just the intuition of it, not going into much deep mathematical analysis, but just the intuition of it. Suppose I want to train my large language model to predict where is Taj Mahal. Okay, so if I ask a large language model the question, where is Taj Mahal, it predicts that it is in Agra, or the next word in the sequence should be Agra, right? And I know this answer because I have this text in Wikipedia. I have this text that the Taj Mahal is on the right bank of River Yamuna in Agra. Okay. What I will do is I will cut this sentence from any random place. Let's say I cut this sentence from this place. So after in, I cut it. Okay. And I ask the language model, okay, take this input. The Taj Mahal is on the right bank of River Yamuna in, and predict what can be the next word in the sequence. Okay. So what it will do is it will predict this large language model according to whatever value that they have stored on their weights and biases. They will predict some word, right? This is training I'm talking about. Okay. When I'm training this parameter, when I'm obtaining this parameter, how I will obtain this parameter is what I'm talking about. So I will say, okay, take this sentence, the Taj Mahal is in the right bank of River Yamuna in, and on the base of whatever parameters that you have, predict something. Okay. Let's say that it predicts Agra. Let's say that it predicts Delhi by whatever reasons. Okay, it can predict any gibberish word, any word that you might even not that is there in the English dictionary. Let's say that it predicted zebra, which is absurd, right? It can predict anything because it doesn't have any context right now. Let's say that this is my first sentence that I am training this neural network with, and I say the Taj Mahal is in the right bank of River Yamuna in, predict me anything, and it predicts some random shit. So it predicts Delhi, let's say. Okay, so I know that my answer is Agra, right? So I will make that calculation. I will calculate this error. Okay, so how much difference is between Delhi and Agra is the answer as a word vector. Okay, I'm not saying that the distance between Delhi and Agra, nothing like that. So Delhi as a vector, Agra as a vector, and how much difference is between these two vectors. And this error goes into this large language model. And inside this, some calculations happen. Um, so these weights and biases, they get adjusted. Some values of these weights and bias adjust up to a point that it always predicts the right answer, which is Agra. Okay, so these weights and biases, they adjust accordingly, so that the next answer in this sequence should be Agra. So whenever I write the Taj Mahal is on the right bank of Yamuna in, so it will always predict Agra as the right answer. So this we will do for each and every sentence that is there in the English in the corpus. Okay, so I cut a sentence, I ask it to predict the next word. I cut a sentence, I ask it to predict the next word. And by adjusting and readjusting it parameters and the values of these weights and biases, it learns the gist of English language. So if I say the Taj, it knows that the next token will be Mahal. Why? Because it has adjusted its parameters on by training on all the text that is there in the English language. It knows that after Taj, the next word should be Mahal, because this is what it has learned in this training sequence, right? And we train this on all these GPUs that are there, and it's a really rigorous process. So we make a kind of like we make a factory of where we put in all these GPU clusters, and then we take this large data set that we have that runs on all these GPUs again and again and again. For each sentence in the English language, it is cutting that sentence from half, asking it to predict the next token, cutting that sentence in half, asking it to predict, and learning what word comes after what word by this in this process. This is kind of like a gist of how it learns, but we will go into deep and detail of how the language modeling or predicting happens. And this learning of um, this English language, or this learning or predicting, happens through this architecture or this model called transformers. Okay. So if you see the full form of GPT, the full form of GPT is also generative pre-trained transformer, and this T here is transformer. So it is a generative model which is pre-trained. That means that we train it prior, and it is a transformer architecture, right? We train it on transformer architecture. That's why the full form of this GPT is also there. Before I start my transformers as a topic, I just want you to just let me know how many of you have heard about transformers before. If you have heard, if you have any idea about what transformers are, can you let me know? Okay, so if you have, you can also say I have. And if you have, if you don't have, then you can say I have never. All right, Shraddha is asking, I didn't understand the purpose of neural network in LLM. Like, why neural network is used in LLM and what are the nodes that represent in LLM? So, take neural network as kind of like a brain of uh, emulation of human brain. Okay, so in human brain, there are many nodes and branches, right? We have these neurons inside our human brain. So, similar architecture we are also attaining in computers by creating these nodes which hold some value, and there is a connection between each nodes that is there, and by adjusting its values inside these nodes, it is able to um, perform tasks which are intelligent, right? So I say that if I want to learn language, I have this whole um, system of artificial neural network which has stored some value in its nodes, and which is stored as weights. And by learning these weights, if it gets any input on whatever weights that it has learned from, it produces some output, right? So my how human brain learns, right? So if I have touched some hot object in my past, then my neurons must have been fired in my brain that, oh, this is dangerous for my body, and they must have generated a response whether I take my hand back or not. So some value is stored in my neurons that is there, and on the base of the input, this value is being called upon, and on the calling of this value, this response is being generated of taking my hand back or not. All right, so a lot of people are talking about yes, they have heard about transformers, and Pranjal is saying that he has also read "Attention is All We Need." It's a really interesting article. I will also talk about this research paper, and so Shivam is asking, when we are asking ChatGPT to code some program, how will it work? So we are training it with all the text that is there in the English language that includes code as well, right? So we go to GitHub, whatever people have typed before, whatever code is there, it is just predicting what code it should generate next. So if I say, generate me a program in C, then it knows, okay, what should come after generate a program in C, because that's also it has learned from the English language, and it also has this attention mechanism which we will talk about, by which it predicts the next word in the sequence. Prashant is saying that I have to make an AI chatbot for my application, then how I have to collect all this data and store it as a parameter. It's a very tedious process. If you want to make a chatbot for your application, you don't need to do all this exercise. You have these foundation large language models. You can take any one of them. Designing your large language model is not very easy. Okay, it requires millions and millions of dollars. It requires GPUs. It requires a lot of time, and it requires a very big facility to design these large language models. Even like DeepSeek, even if you want to design DeepSeek, still it takes a lot of money and resources. All right. So thank you so much for your amazing, amazing questions. I am sure I'm sorry that I cannot read all of your questions, but I will try to read as many as possible. But we also have time to beat in this class. We have a lot of content. So if you have heard about transformers and you are thinking about these kind of transformers, then I am sorry that these are not what I'm talking about. And if you have heard about transformers and if you are talking about these kind of transformers, then also these are not what I'm talking about. These are more in terms of electrical engineering and the transformers that are there that steps up or steps down the electricity. What I'm really talking about is this type of architecture, this complicated architecture, which I will explain in very, very simple terms in the next 10 minutes, 10 to 20 minutes about the transformers. So someone said to me in the chat box that they have read this beautiful research paper, which is Attention is All You Need. And this research paper came in 2017. Okay, so I'm really proud to say that there were two Indians in this research by Google's DeepMind, and in this uh, in this research, what they researched is that there is an architecture called transformer architecture, which can be used to understand language in a very better way. And the underlying principle of making the language understand each other is the attention mechanism. Okay, so if you pay attention to certain words in a sequence or in a sentence, you will be able to identify the meaning of that sentence. All right, so this is a beautiful the beautiful research paper 2017. It was published by Google's DeepMind. And in this, if you talk about like transformer architecture, then it has two parts. One is the encoder part of it, and one is the decoder part of it. So if you talk about transformer, we can divide it into encoder and decoder part. Both of them together is used for translation purpose. So if you talk about like Google Translator or any language translator, then encoder and decoder part both are used. But if we talk particularly about the language generation or the generative AI, then only the decoder part of transformer is used. All right, so we'll not go into discussion about the encoder part of transformer because that would become a again a 3 hour long class, and we don't have that luxury of time. But for generation purposes, we only use the decoder part of it. Okay, so the decoder part of this transformer architecture is used for the generation purposes. So what are the parts of this decoder part of transformer architecture, and how can we make it simple to understand is what my next 15 minutes will be about. So think of this transformer architecture as a 5-story building. Okay, so the first or the ground floor of this is output embedding. And then there is the second floor, the first floor, which is the positional encoding. The second floor is this masked multi-head attention layer. The third floor is this feed forward network. The fourth floor is this linear layer. And the fifth floor is this softmax. And after fifth floor, you get this output or the output probabilities. Okay, very simple, that we enter a building from the ground floor and we leave that building from the fifth floor. Okay, so just take this as an analogy of understanding this transform architecture. Okay, so all these words, apples. So let's take an example. If I say apples are a type of delicious, what can be the next word or what can be the next token in the sequence? Okay, so if I say apples are a type of delicious, then the next sequence in this token can be fruit, right? Which is how human beings are trained. I know what an apple is, and I know the delicious part of it. If I have said apples are a type of um, luxury, then my next word would have been say laptop, right? Because apple is also a type of laptop. Apples are a type of um, um, what machines? Laptops, right? So depending on what my context is, so here I am predicting this next word in this sequence, which can be fruit, right? Apples are a type of delicious, and I'm predicting the next word in the sequence. I don't know what the next word in the sequence is right now. My machine doesn't know, right? Machine doesn't work like humans. So in my first or the ground layer, I will feed all these words as tokens, and I will generate these tokens as word embeddings. Okay, so computer doesn't understand these words; it only understands numbers. So these words have to be changed into numbers, and these numbers or vectors we call as word embeddings. Okay, so a simple way of how computer understands language is that it uh, to understand what word vectors are or what are word embeddings, there is a very simple exercise that we will do. Okay, so if I type in this question, king minus man plus woman equal to what will be your answer to this question? Okay, so if I say king minus man plus woman equal to what will be your answer to this question? Okay, let me know in the chat what will be your answer. All right, so Mohammed Karim is saying that queen will be the answer. Yeah, that's the right answer. Jeel is also saying queen. And Kushagra is saying queen. And Sakshi is also saying queen. Amar is saying children. That's something which is weird. King minus man plus woman equal to I don't think that children can be anywhere near in this. All right. So a lot of people are answering. Dhruvi is saying Another one transformer is Bert, bidirectional encoder representation from transformer. Yes. Mayank is saying queen is the answer. Yes. Sujal is also saying queen. All right. So how did we get this understanding? King minus man plus woman equal to what? It's queen, right? And why? How did we do that? Like, how can we add and subtract words? Like, we can only add and subtract numbers, right? We like from since childhood we have been only adding and subtracting words. So how can we add and subtract sorry, add and subtract numbers? How can we add and subtract words is what we think about. So taking this understanding that these words don't just have a representation, like this symbol is there. So king is just a symbol, right? It also has a representation. So if I say king, then in my mind I am actually mapping this king as a symbol to a meaning in my mind, right? So king as a symbol will have a meaning in my mind, which is a position or a leader of a society. And man also, man as a symbol, has a meaning in my mind of a human male. And woman has a as a symbol, WMAN, as a symbol has a meaning in my mind of a human female, right? So if I say a leader of a society minus male, okay, so that will just become a position. And if I add a woman to that position, it will become queen, right? So word don't only have a value to it, but they also have a direction to it. All right. And that's that understanding of words um, uh, as vectors, meaning they have a value and also have a direction, was very important in order to make computers understand words in a very easy way. So to calculate these words, what we will do is we will represent this word as vectors. And similar way, like king minus man plus woman equal to queen, India minus Delhi plus Paris equal to France. So all this understanding that we can get by adding and subtracting words. So if I talk about this in very simple language, I can only draw these word vectors in 2 dimension. In reality, they are like 300 dimensional vectors. So if I see these words in this vector plane, then the words which have similar meaning will lie in the same direction, and words which don't have similar meaning, they will be parallel to each other, perpendicular to each other. All right. So if I talk about getting this result, if I talk about king, man, and woman, then these word vectors will be like this. So king will lie somewhere here, woman will be like here, man will be like here. And if I add this negative of man to king and I add this woman vector to this vector, then it will give me this queen vector. All right. So uh, just by adding and subtracting these vectors, I will be able to understand the similarity between these words as vectors. So how to make these vectors? One way is to use one hot encoding. That means that all the words that are there in the English language, I'm giving them each word a separate number. Let's say that abacus is coded as 1 in the 5th position. Aardvark is coded as 1 in the 1st position. All the other words are 0. So this is one very simple way of coding these words as vectors, as one hot vectors. In this coding, all these words that are there are different from each other. They have no similarity between each other. Okay, so they are like orthogonal to each other. One more way is to denote them by word count. We have all these documents, different documents in my corpus, and I'm counting how many words are there in this document. And this way we were using for language modeling, right? So we were counting how many times a word has occurred in the English in some particular document, and on the base of the frequency of the words, we were predicting the next word. And one more type of word vector representation is co-occurrence. How many words are occurring together in my whole corpus? How many instances that I am seeing all these words occurring together? And this whole vector of these words are what the word vector is. All right. So simple ways of making these words as vectors. So this is not how actually it happens. Like the word vectors, if we do it like this, then it will be each word vector will be like 170,426 dimensional, because these many words are there in the English language, right? So basically, each word has a 300 dimensional vector, and that is out of scope of this class about how we obtain these word embeddings and what is the word to vec algorithm is about. But just to give a gist of it, each word is being represented by this word vector, which we will use to find some similarity. And each so all of these words, whatever words are there in the English language, we make them as vectors, and we find whether these two vectors lie in same direction. So if two vectors they lie in same direction, they will have more similarity, and if they lie in perpendicular direction, they will have no similarity. And we can get this understanding by calculating a Euclidean distance between these two vectors, or by cosine or sine similarity by multiplying these two vectors as dot product. All right. So not to go into too much math and make this a more theoretical mathematical class, I will just skip that part. Just to remember that these words are whatever tokens that we are feeding this to a word embedding um, uh, layer of this transform architecture, we are making these words as vectors. And by making these words as vector, two words which are lying in a same direction, they have similar meaning, or they have similarity between them, is what my computer is learning. Okay. The second layer of this is positional encoding, because we are sending all these words as vectors parallelly to this word embedding layer. In positional encoding, what we need is we need to give each token it a number, so that we know when that token has entered my system, right? So if I talk about any language, the position of words, they matter in any language. If I say dogs eat bones, and if I say bones eat dogs, if I change the position of dogs and bones, then it will become an entirely different sentence, right? Although it is grammatically correct, but it doesn't make any sense. So I also need to know in which order my input is coming. All right. So what I do is, all my tokens, I add a number to them. So app is given 1, less is given 2, R is given 3, A is given 4. And in this way, I have ordered uh, all my text. I have numbered all my text, and I know what is the position of each token in this sentence. All right. So after positional encoding, I go to this main or the most important part of my transform architecture, which is a masked multi-head attention layer and a feed forward network. I will go through this in a very intuitive way, not to go into detail about attention layer and all. Otherwise, we will be having this class for too long. But let me see if I can make this explain in very, very simple language. So what is attention mechanism? Okay, so in English language, the dictionary meaning and the contextual meaning of words in a sentence are very different. Okay, so the way we speak language is not always about dictionary meaning of the sentence. So if I want to know the meaning of a word in a sentence, then I don't only refer to its dictionary meaning, right? We also need to understand the context of the sentence in which it is writing, or in which it is written. Okay, so a simple example that I want to explain is, if I say the elephant could not fit in the car because it was too big. Okay, so this it in this word, what does it represent? Okay, so if I say that, okay, I want to find the meaning of it. Okay, in my dictionary, the meaning of it is in my dictionary, the meaning of it is used for um, uh, non-living thing and also an animal, right? But in this case, I have an animal also in my sentence. I also have a non-living thing. Okay. So if I want to know what is the meaning of it in this sentence, okay, let me know in the chat box what can be the meaning of it in the sentence. Okay, what does it refer to? The elephant could not fit in a car because it was too big. Okay, so this it, whether it is car or whether it is elephant in this sentence, just let me know what is your answer. Okay, so Sehul is saying that elephant, yes. And why elephant? Because when I pay attention to these three words, okay, so if in order to understand this sentence, I don't need to understand each and every word that is written in this sentence. If I just pay attention to elephant and car and big, I will be able to figure out the meaning of it. Okay, so if I say elephant and car and big, so if I pay attention to big, I know that out of car and elephant, only elephant is bigger, right? So this it cannot mean car, it can only mean elephant, right? All right, so a lot of people in my chat are saying king wo can also be an answer, and that's kind of like a very literal or very crude way of adding and subtracting words. King minus man plus woman, you subtract man from man from WMAN and then add WO to it. But what will you do in the case of India minus Delhi plus uh, let's say Paris? That gives you France, but in that way you can't do this. All right, so a lot of people are saying elephant, and that's the right answer, which is because as a English language, as a human, I only paid attention to elephant and car, and I knew that the it will always point to elephant. But if I pay attention to, if I change this, right? If I change this to this sentence, the elephant could not fit in a car because it was too small, right? The sentence is same, only I change the last word of this sentence. Now, what will it point to? Right? So if I changed my sentence, then my context of my sentence changed. And if I pay attention to elephant, car, and small, if I pay attention to small, then I know that small is not a property of elephant, right? Elephant is always big. Small is a property of a car, maybe. Out of these two, smaller can be car, but elephant cannot be small, right? Elephant can be only always big. Elephant has this inherent property of being big. So if I say it here, it will always represent car, because if I pay attention to small, then in my sentence, the context of it will always become car. So what happens in attention mechanism is, quickly I will go through, each word vector is divided into three word vectors as query, key, and value vectors. And these vectors are derived by multiplying the input embeddings by trained weights, which we acquire in the training. This is not a natural language processing class, so I will just skip this. These apples, the query vector of the sentences, the words here are multiplied with key vectors of this word, and a value is being retrieved. So basically, what we are doing is, in the input that I have put, I am multiplying the value of each word, the query or query vector of each word, to the value of each word that I have obtained by training, and I'm getting some value. Okay, so if I am multiplying these values, I'm saying that, okay, how many, this is my input, and out of this input, which words have more context of each other. So apple and delicious have more context of each other. Apple will have more context. Apple and type have more context. Okay, so I give a value of this. After this exercise, I will attain something like this. And out of these apples are a type of delicious. Based on this score, I will know which words I should pay attention to in order to get the next word. So if I pay attention to only apples, type, and delicious, based on the values of these apples, type, and delicious, I will be able to know the next word in this sequence. Okay. So if I know apple and I set apple and type, I I am already in my sentence, I'm already talking about what is the type of apple, right? And if I add delicious to the context of it, then if I say that apple and delicious, they have a quality and they refer to another word vector, which is maybe fruit, then that these three words are the words that I need to pay more attention to. All right, so when I pay attention to certain words of the sentence, then I will be able to predict the next word more properly. All right. So this information is being fed to a feed-forward network that imparts some of the non-linearity in it. Right now, the layer is more linear. So here we will impart a non-linearity to this, and we use a non-linear function, which is a ReLU function, which is very popular. So basically, what we are doing is, linear systems are very unreliable. So we impart some non-linearity in order to be the system more robust and reliable. And after a feed forward network, we go to a linear transformation model where we map the next word that is there in the sequence to all the words that are there in the English dictionary, and we give it a score. So let's say that apples are a type of delicious. There can be many words that it will predict. And of all the words that are there in the English dictionary, it is giving them a score based on whatever context in this, or whatever attention that it has got from this context. Okay, so if I pay attention to apple, type, and delicious, the next word in this sequence can be a fruit, can be laptops, can be snacks, right? If I pay attention to apple, then the next word can be laptop also. If I pay attention to apple and delicious, then snack can also be next word. Apples are a type of delicious snacks also. People use apples as snacks, and apples are a type of delicious fruit is also the next word that is there in the sentence. So all these three words, fruit, snack, and laptops, they will get a score on the base of how much context that they carry from the sentence that is there. And then this whole mapping of to all the words that are there in the English language, in the last layer, we will just do a softmax. That means that we will adjust it to a probabilistic distribution where the word which has the highest probability, which has the highest score, will be given the highest probability. And in this case, the word that has the highest score is fruit, and it will be given the highest probability. And on the base of that, we will predict what can be the next word in the sequence. So apples are a type of delicious. Fruit will be the answer. Although there can be many answers. There are like many answers in this, but the word with the highest probability will always come. All right, so I will give you an example of this on ChatGPT, asking this a question like apples are a type of delicious. Okay. Okay, so it says delicious fruit. And if I say complete this, apples are a type of delicious fruit, and sometimes it also gives me another answer. Okay, now it has learned from my response and it is always giving the same answer. But if I type in apple is a type of delicious, yeah, it's saying fruit only. Now it is more going into probabilistic way. But I once or twice I have also kind of like got an answer of apple is a type of delicious snack, and that's what I was going to show. But it never behaves in when you are showing something to someone. But yeah, the idea behind this is that the large language model is always predict the word with the highest probability, and it will predict a number of words, and it will map them to the highest predicted one. All right, a lot of theory. Before we move on to part 3, which is fine tuning, just give me a quick pulse check if you are focusing or on the right track or not. So what is the data which we'll train large language model called? So if we are training large language model and we talk about training, so what is this data called? Huge data, Morpheus, corpus, large data, whatever is the answer. Please let me know in the chat. And till then, I will also read your interesting question. Thank you so much, Heyman, for saying corpus. Shraddha is saying corpus. Yes, it is called corpus. That means that you are on the right track. You are learning from this. Shivam is saying corpus. Yes. Um, uh, Trish is saying corpus. Yes. Thank you so much for replying. And Prashant is saying elephant because first subject will include. Yes, if we pay attention to the sentence, then we will get to it. Ajit is asking why apples was divided into two parameters, app and less, because app is also a word there, right? So in the English language or in the word dictionary that is there, app is also something that we use, an application, shortcut for an application, right? So it doesn't take apples as one word, it takes app and less. And that's so tokens are words. Sometimes they are symbols, sometimes they are word chunks. They are not actually words as words that we see. It's based on the probabilistic calculation or byte pair encoding of two um, uh, s- uh, two characters occurring together in a sentence. So that's why apples is not a single token. It is divided into two tokens, app and less, because that's how they are more, they give more sense to the language model to understand from. All right. Thank you so much for being so much patient and being so much focused. I know it's a lot of theory, and I almost have covered a lot of NLP in this lecture itself, which is really commendable that um, you have been listening to all of this, replying to all of this, and understanding this. Uh, it is really difficult to understand AI sometimes if we go into its core, and that's the beauty of it. Like if it was easy, then everyone would have been doing it, right? So you are basically are on a right track, and I believe that it takes a huge amount of courage in order to learn something new, and I congratulate you on taking that step towards your own learning. Okay, so Sakshi is saying that, sir, if LLM are trained on internet text, how do they avoid learning wrong or biased information? Yes. Okay, so this is what fine tuning is all about. Okay, so once we very interesting question, Sakshi, that okay, it can also learn bad things and it has learned bad things, but how can we make it more not to learn from these bad things? So first of all is we include this data. So there is a job called AI ethics and AI uh, yeah, AI ethics, where we design all these ethical AI systems. Where in the first step, it all only we are separating the data that is not good, and we are not training our model with that data. And second step is that even if it has trained from that data, we fine tune it according to how we want it to behave. Okay, so one interesting question that I got was how LLMs know that they don't have to repeat their answer. So it's a probabilistic language model. They can repeat. Okay, so what is the probability that I roll a dice and a six will come? Right? It's 1 by 6, right? So out of my six chances, there is one chance that I can get a six, right? And what is the chance that I get a six after a six? Right? That can be then again 1 by 6 into 1 by 6 or whatever probability calculation that can be there. Mm, so there is a chance that a large language model can repeat its answer. It's a probabilistic model, right? And we are also making sure that in this probabilistic model, the word which has the highest probability is only getting printed. And that way, the large language model always knows which word to give priority to in order to print. It can print any random number, yes, of course, or a random word. But when we are training it, we are making it to adjust its probability to a level that whenever it is predicting the next word in the sequence, it is always predicting the highest probabilistic word that is there in the sequence, right? All right, so let's come to our third step, which is fine tuning. And after a large language model is trained on a large corpus, it is fine tuned according to our needs. Okay, so when you make a large language model, you train it on all the text that is there on internet. It is giving you this probabilistic calculation, always giving you the right word that you want to predict in the next as a next token. But what if it does something wrong? Or what if it doesn't know something? Let's say that you have a hospital, okay, and you want to design a chatbot for your hospital. Somebody said, how can he design a chatbot, right? So you take a base model which you have trained, like ChatGPT's base model, and you train that base model on your medical data. Okay, so you say that, okay, this is my medical data that I have. You take this medical data, you train on this medical data, try to predict the next word in the sequence, learn from this medical data, and then give me the answers. So let's say that there is some word called COVID, and which is let's say let's not take COVID, which is very popular. Let's say then some other disease comes next. Let's say it's um, uh, COVID 560 or something like that. Okay, and the ChatGPT's pre-trained model doesn't have any context about COVID 560 or the variant of COVID. So what you will do is you will take your data that, okay, this is COVID 560. What is the definition of COVID 560? And all the text about COVID 560. And you say that, okay, now train your language model about this from this document about COVID 560. And it will now fine tune its answers about this. It will adjust its weights and parameters in order to also answer about COVID 560, which it did not know prior. So this is called fine tuning your answers on the base of this is called transfer learning in general. So fine tuning can happen with different ways. One by human feedback, one by dataset fine tuning, which I talked about. Transfer learning is also one of the way. Few shot learning and prompt engineering. Right. Last class we saw right how we were fine tuning ChatGPT to give the desired output. I said, okay, take this model, take this example of how Apple names its products. It adds I to every product, and it was giving me that answer only, right? So I was able to hack ChatGPT into saying something which it should not say by just prompt engineering, by fine tuning its answer, by giving examples, giving it specific prompt, and all these things. One most important thing in this fine tuning is reinforcement learning with human feedback. Okay, so ChatGPT, when they launched their model, they opened this model to the general public and they said that, okay, learn from this model and let us know whether this model is writing the right response or not. So let's say that if a person asks for repo rate, which is kind of like a economic term, and ChatGPT's response is like this, which is what it has learned from internet, right? So it says the repo rate is interest rate at which a country's central bank lends, whatever. It is more of a formal language, right? And ChatGPT was trained to give a response um, in which the human beings like. It should have a level of personalization. Okay, so whatever response ChatGPT generated, a human being, he watched that response and he said that no, this is not how you talk. You talk like this. You say the repo rate is the interest rate charged by a nation's central bank when lending money to commercial bank. Make it more human, make it more simple. Okay, and they fed this response to ChatGPT again. Okay, so they said that, okay, this is what you have generated. No, this is not how you should have generated it. This is how you should have generated it. And then the large language model, they adjust its weights and parameters in order to generate the response that is more human. All right, and also you will see these things in ChatGPT always, that there is a example of a feedback that you can give to ChatGPT. If I go to my ChatGPT, I know that, okay, good response, bad response. If I say good response, it knows that, oh, okay, now this is the desired result that I want. And if I say bad response, then I say that, okay, it's not the desired result that I want. And this is also one way that we can fine tune the response of ChatGPT. This is called reinforcement learning with human feedback, where human being is giving feedback to any model, whether or not how it should generate what it has generated. All right. So far, we have been talking about text generation and all. For the next half an hour, we will talk about the image generation and we will conclude this today's class. Before going to image generation, just answer this question. If you have been paying attention, then what is the mechanism that allows transformer to know about the contextual information of the word? Is it suspension? Is it transformation? Is it attention or embedding? Let me know in the chat. And also, I will read your questions, of course. Okay, so the answer to this question is Shraddha is saying the apple word is very normal word and it adds to dictionary. So why the LLM does not found the whole word apple in its dictionary? So it's not about adding the word to dictionary. It's more about like what is the most common byte pair encoding between two words. So let's say that um, uh, if I have two characters occurring with each other, how many? So apples is, yes, of course, apples is a word that is found more in English dictionary, but apples is a word and app is also a word, right? So the instances of app coming together are more than the instances of apple coming together. Why? Because app coming together is also happening in apple, and app coming together is also happening with app, right? And that's why the instances of coming as app is more. The count of app together is more than the count of apple together. Yeah. Do you agree with me or not? Right. So that's why app would be a token. a sentence, a token, right? Because APPLE as a token, yeah, it is right. But APP together is more than APPLE in the whole dictionary, and that's why it is taken as a token. All right. All right. So answer to this is attention, and that's the attention mechanism. Um, is the right answer. Ansh is saying that he prompted ChatGPT to make the tone more like Gen Z, and it changed the wording. How does they do that? How does they do that? What to? How does they know what to create tone like human? So if you say now, see the this is how ChatGPT was initial, right? So it was generating something, and then we were doing it reinforcement learning and all these things. Now ChatGPT has ingested so much context because we have been continuously talking with ChatGPT, right? It is also self-training itself. So if we are talking, if I getting talking to ChatGPT, it is understanding from my when I'm feeding a ChatGPT something, it is also understanding, learning at that point of time also, right? So now it has so much context about English language and all that it can generate far 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 better answers than it was generating initially. Prashant is saying, can I add any LLM in my application as chatbot feature? And as we had to make a tweet, as we had, yes, you can add any LLM in your application as a chatbot feature. You just need to call their API keys. Okay, so they have made their LLMs and they distribute these LLMs to their own UIs, but they have these APIs which you can call to their backend servers and then fetch the data from there. So if you want to use any LLM in your application, you will have to get in their API keys. But not all LLM offer their APIs for free. So Gemini offers its APIs for free for some versions like Flash 2.50 and Gemini Flash 2.5. But for OpenAI, if you want to use their language model, then you will have to take in their API key as a pay per subscription model. So if I just show you how it looks like is you have I have like these API keys. So you go to uh, OpenAI API and inside that you get your own API keys and then you use these API keys in generating this. All right. So I'll just show when it unloads. But we still have like half an hour left to talk about language models. So I will skip the questions to the last. All right. So in order to understand how any any uh, uh, any model generates, we talked about text generation, right? Now we are talking about image generation. How a model generates images. So let's learn about that. And before going into image generation, let's learn about what are the two types of AIs that are there. Okay, so one type of AI is generative AI, which generates something, and one type of AI is also discriminative AI. Okay, so if we talk about a discriminative AI, they have these convolutional neural networks in there, which takes an image. Okay, so this image is there of a cat, and this discriminative AI, what it does is it classifies this image as a cat or a tiger. It so one is image generation from the word cat, generate the word image, and one is the detection or discrimination that from this image, what is this image about? Tell me about that. Okay, so if I talk about generation, then I type draw a cat and it generated me this. And if I talk about discrimination, I give an image of cat and it predicted a cat out of this image. And why it is important, it will become very handy when we talk about generative AI tools in image generation. Okay, so discriminative AI is how it works is that I have an image of a cat, okay, and I want to predict whether the image is a cat or a dog, okay, and this is classical machine learning we are talking about. So what I do is I will train this neural network. So this neural network, and this will become clear more about the words also. This is how the words also work. So I am predicting which is what is this image about. Okay, so this image is a cat or this image is a dog. I am predicting with this neural network. Okay, so what I will do is I will train this neural network on lots and lots of images of cat. Okay, I will show lots and lots of images of this cat as an input to this neural network. Okay. And these weights and biases, they adjust in this neural network in order to predict cat. I say that, okay, all these images are cat. And in this process, these weights become more important. Okay. So these weights that I have shown here by red, they have more value. Okay. So a combination of these weights is what is predicting the next word in the sequence, which is cat. Okay, so this neural network in this process of training again and again with these cat images, they learn these red nodes. Okay, so a combination of these red nodes is what cat uh, is what will predict cat. Similarly, we will do it with dog images, and a combination of all these yellow nodes will predict that it is a dog. Okay, so in the training, I'm training this with many instances of this cat, many epochs, and in this process, it is learning some weights. It is storing some weights in these nodes, and these nodes are getting fired. So basically, weights are these branches from one node to other node. But just to give a more intuitive way of understanding, that these nodes are getting fired whenever I show a cat image to it, and these nodes are getting fired whenever I show a dog image to it, and whenever I show any other image to this, let's say that I show a cat image, the same nodes will get fired, which fired when I was training this neural network for cat image, and that's why it will predict me a cat. Okay, so this is how discriminative AI works. So I feed an image, the same neurons will get fired when I was training this neural network with the same type of animal, and the combination of these neurons will predict that this is a cat. And but in generative AI, what we'll do is we will just prompt a text input, draw an image of a cat, and it draws me a beautiful cat. How does this happen is what we need to think about. So there are many different image generation methods, and three popular methods. First of them is a GAN, which is a generative adversarial network. And then there are diffusion models, and then there is stable diffusion. We will talk about all these three in very detail here. So I will skip the questions for now because I will take questions in the end. So GANs or generative adversarial networks, what are they and how do they generate image? Okay, so a very um, low level of image generation when we started generating images was to generate image from a random noise. Okay, so we have two systems, two AI system, two neural networks. One is a generator. Okay, one system is a generator and one system is a discriminator. Okay, so this generator takes an input as any random noise like this, like you see when you don't have any network on TV, right? So it takes in any random noise like this and it generates any random image. Okay, so we say that draw an image of cat. It takes this random noise and it generates any random image, okay, which doesn't look like a cat now. It generates anything random from this. Now this discriminator, we have a discriminator which we have trained to detect cat images. Okay, I say that, okay, this discriminator says I am using the training data. It knows what a cat looks like. It knows the features of cat, right? It is trained to discriminate what a cat is. Now I say generate a cat. Why I'm saying generate a cat? Because my discriminator is trained on cat data only. It can only generate things in which it is trained on. So I took this random image, random noise, and I generated a random image, and I went to the discriminator and I said, does the image pass as a cat or not? Okay. This discriminator knows what a cat looks like from its training data, right? It says, no. This image does not look like a cat. It does not pass as a cat. So it says true or fake. It says fake. It goes again to the generator. The response that is there, it goes again to generator. It says that, oh, whatever image that you generated was fake. Okay. And this was that much error. So it knows how cat features are. And it knows that this is not an image of a cat. So it goes back to the generator. It says, okay, generate again. So in second process, it generated this random image. Okay, second process, learning from the error, it says that, okay, I generated this. Now, this is not just the second process. Okay, this happens after hundreds of process. It generator generates something random. It goes to discriminator. It understands the error in there. It goes back to the generator. It goes back to discriminator, understands the error, and the process happens. And after some time, it starts generating something like a cat. But discriminator is still not satisfied. It says that no, this is still noise. This is not an image of a cat. Then again, it generates something else and it generates some image of a cat. It says that, okay, now I have generated this. Will it pass as a cat? Discriminator says no, it doesn't pass as a cat. Again, it generates something, and until and unless it generates an image of a cat that passes the image of a cat in this discriminator, it generates this image. So it's an iterative process where you feed in random noise, you tell a generator to generate something random, it generates something random, and you feed it to discriminator says that okay, this is right, this is the right image or not, and then it generates the right image in this iterative process again and again and again and again and again and again, generating this image until and unless it generates an image that passes the image that we want to generate. Okay, so this is one way, and this is how GANs work. So you use two, and that's why the full form also is generative adversarial. Why adversarial? Because these two, they work as adversaries of each other. These two work as if they are enemies of each other. Generator tries to beat the discriminator. It says that I will design a perfect image that discriminator will not be able to catch, and discriminator says, oh, I am trained up with all these images. Whatever image you will give me, I will check whether that matches my discrimination or not. Okay, so generator is trying to fool the discriminator because this is not a real cat image. It is something which is very imaginary. But discriminator is also trying to detect whether the image is right or not. And in this process, by generating it again and again and again, it always generates the right image. Well, this is how a simple image generation works. GAN. Another model is a diffusion model. Okay, so in a diffusion model, we generate images from random noise by following a series of steps. So in this GAN, we were generating it from a random noise, a completely random noise. In a diffusion model, what we will do is we will add noise to pictures and train the neural network to predict the original picture. So I say that, okay, this is my original picture. I add some noise to this picture. Okay. And from this noisy picture, I ask the neural network to predict me the right picture. Okay, so इस पिक्चर का ही ये noisy picture noisy है. So I say that okay, from this noisy picture, construct me the original picture, and in this way, it will learn what the original picture was about. Okay, so I say okay, they take this random picture, learn something, some features of it, and try to predict this. Okay, so in order to predict from this picture the right picture, it learns these three, let's say that these three nodes get fired. Okay, if I add more noise to it, more nodes will get fired. Why? Because it has to now capture more information about this cat from this image, because now it has to generate this from a very noisy image. And then when I give it a very noisy image, then more information it will need to generate this image from an image that looks like this. So what we will do is we will train all of our GAN with lots and lots of pictures by gradually adding a noise to it and then trying to predict the original picture. We say that, okay, this is a cat. I add a noise to it, predict what cat is. I add more noise to it, predict what cat is. I add more noise to it, predict what cat is. And I add more noise to it, predict what cat is. And in that process, learn the parameters that are required to generate this cat image from a random image like this. And then we train it on all of our pictures. And in this way, the neural network have the information about what a cat looks like. So from a random noise, if we say generate a cat, it always generates a cat, because now it has stored all this information in its parameters, what a cat looks like and how it can recreate the original image. All right. So diffusion model is we gradually add random noise to a picture, and then we train this model on thousands and thousands of pictures of a same same picture that we want to generate. And by a random noise using the diffusion model, it always creates the right picture. And third, or the state of the art, which is stable diffusion, it takes two things as addition. One is CLIP, contrastive language pre-image training, and latent diffusion model. So both of them added together make what stable diffusion is about. So to give you an intuition of what stable diffusion is, right now we were talking about training a system on a particular type of image generation. Let's say that if I want to generate cat images, then I will train a system to generate me cat images, right? It will not understand my prompt. If I say a dog wearing a hat, right? So how does it understand a dog wearing a hat? It has two components. It has a dog, it has a hat. Now I have to train my system on pictures of a dog wearing a hat, which are not many, right? So how can I make a system that also generates something which is not there? So this stable diffusion model, what it does is it uses this contrastive language image pre-training, which takes this prompt into a tokenizer and this um, token to embed, and it gives me these text embeddings, which we learned about when we were talking about transformers. And these text embeddings are mapped with image embeddings. Okay, so let's say that I have a dog called Pepper, the Aussie pup. सो उसका कुछ टेक्स्ट एनकोडिंग होगा, राइट? सो उसका टेक्स्ट एनकोडिंग जो वेक्टर है वो ऐसा दिखेगा. एंड आई हैव अ इमेज ऑल्सो ऑफ द same text. So if I'm talking about dog, then I have images of dog also. So from these images, I encode these image to a vector, right? To a single vector. So I use convolutional neural network and I encode these images to a single vector, and I make a correlation vector between text encoding and image encoding. So I map each text. So if I say dog, I map that with the image of a dog. If I say cat, then I map that with the image of a cat. So my computer now stores two embeddings. One is for the text, which is dog, and one is for the image, which represents dogs. And if I take take this diagonal of this vector, then I get the encoding pairs. So I1 with T1, I2 with T2, I3 with T3, and so on. So each word in the English language is trained with its consecutive image. So if I say dog, then it is trained with a dog. If I say chair, it is trained with a chair image. If I say a man, it is trained with a man image. Okay, so my contextual information about the word as symbol and what about the word as picture is now being encoded in a single vector. And second thing, what we will do is I have these uh, latent diffusion models. So in order to understand latent diffusion model and how they work is I have an image in a very high dimensional form. Here it is in a two-dimensional form, or in a three-dimensional form, or in a multi-dimensional form, right? If we're talking about vectors, then it is multi-dimensional. I use an encoder to convert this multi-dimensional image into a lower dimensional image. And when I use a decoder again to convert this image from this lower dimensional image to a higher dimensional image. Okay, this might be confusing at first, but let me talk to you about this in a very intuitive way. So let's say that I want to design a cookie. Okay, I want to draw a cookie, and a cookie in 3 dimension looks like this. Okay, I am not able to draw a very good cookie. So I, on a telephone, let's say my telephone is an encoder. Okay, my mobile phone is an encoder, and I'm talking to my friend here who is a decoder. Okay, and I say to my friend in a very I reduce this dimensionality of this. So this cookie which I was drawing, which I was seeing, was in 3 dimensional. Okay, and I said to my friend, draw a cookie. Okay, here from this phone I said draw a cookie. The cookie should have a radius of um, 5 centimeter. Okay, and a height of 1 centimeter. Okay, so this 3 dimensional image I converted into 2 dimension. One is 5 centimeter, one is 1 centimeter. So 1 dimension is the radius and 1 dimension is the height. Okay, so my friend knows, okay, now he has to design a cookie of 5 centimeter radius and 1 centimeter height. So this 3 dimensional image which I was seeing from my eyes, using this phone as my encoder, I said to him, I called him and I said that, oh, I am drawing a cookie. You also draw a cookie. The cookie should be 5 centimeter in height and 1 centimeter in, 1 centimeter in height and 5 centimeter in radius. And he is able to draw a cookie. Although that cookie will not be similar to the cookie that I am drawing or what I am seeing, but the gist of that cookie will almost be the same like I am drawing, right? So this is how you convert a higher dimensional vector into a lower dimensional vector. And when you decode that lower dimensional vector into a higher dimensional vector, you get the understanding of that. You get a gist of what you tried to design, right? So very simple to understand this. We are basically changing a higher dimensional image into a lower dimension, and then when we are recreating it, we are recreating it with some decoder to that same higher dimension, so that this neural network gets adjusted with its weights and biases to understand about the same image. All right, so using these two together, like contrastive pre-training and latent diffusion models, where we convert them into lower dimension to train our neural network and then reconvert them into higher dimensions in order to produce them, we obtain what we have as Dolly and other models that we have, and which can generate all these different types of images that we have in generative AI now. All right, so we talked about a lot of things. We talked about image generation, we talked about text generation, we talked about transformers, and we talked about large language models. We talked a lot about how all these models generate text and images. And before we go, this is the final question that I have in the chat box for you. In diffusion model, we train our model with adding noise to the image in every step. If you feel that it is yes, say yes. If you feel that it is no, say no. Meanwhile, also ask your questions in the chat box so that I can reply to them. All right, Kushi is saying no. Yes, in diffusion model, we train our model with adding noise to image in each step. I think yes is the right answer. And all right, so this is the final question that I'm asking before we go, and I'm also reading your questions. If you want to talk to me more, and if you want to know more about artificial intelligence and the things that we are designing in artificial intelligence now, talk to me or connect to me on LinkedIn. We are basically creating a lot of AI agents that can do a lot of things. Automate a lot of things. And if you're interested in any of these projects, reach out to me on LinkedIn so that we can collaborate, work together, and make something useful from India to the world. Thank you so much. I will read your questions and answer those questions here. Before I go, I hand over this session to Rashika for any important information that she has. And till then, I will reply to you in chat about the questions that you have. All right, over to you, Rashika. Thank you so much for being there in today's session and taking a step towards learning your own learning journey. I will return back with a more practical session in the next session then when we will design a more robust multi-agent system. But it was really important to understand the underlying principle of large language models, because if we don't know what we are using, then sometimes we are in a blind spot of actually making sense of what we want to design. All right, thank you so much. Over to you, Rashika. I will just reply to all the questions in the chat box itself, and I will read the chat box and reply there.
Okay. Thank you so much, Amit, for today's session. Okay, I'll just quickly share my screen. Some of the important announcement before we wrap up today's session is that tomorrow is the deadline of completing your self-learning module, which is from learner to build an AI agent. Also, my teammate Vaishali is sharing a link of your learning plan on the chat box. Please, if some of you have not yet started, tomorrow is the deadline for that. Click on that link. You will be redirected to the self-learning module. The number one is getting started with artificial intelligence. When you will complete all these modules, you will get one digital certificate, which will look like this. This certificate you can get it by creating a Credly account, and the digital badge you will get this. The self-learning course number 2 is unleashing the power of AI agents. Same, you need to click on go to this activity. You need to do all the modules. After that, you have to identify questions quiz. After completing your quiz, you will get this type of certificate. of your name and the completion activity name, which is unleashing the power of AI agents. This is the second certificate, the self-learning module. This is the self-learning module number 3, which is the rise of multi-agent systems. Again, you need to go to this module, read the module thoroughly, give the quiz of 5 questions, and then after the completion of your quiz, you'll get this type of certificate. And these other digital stickers you will get after the completion of your courses. Also, I am getting several क्वेरीज कि मैम हमने कोर्सेज तो कर दिया है, सर्टिफिकेट्स आ गया, बैचेस आ गया, बट हमको उसको अपलोड कहाँ पे करना है. सो जस्ट वेट फॉर टुमारो. Between, I mean, you can expect the Google from our end, wherein you need to attach all those certificates and badges, जहाँ पे हम आपको एक sample देंगे. Say for example, if you have completed the course of getting started with artificial intelligence, वहां पे हम सैंपल देंगे कि your badge should look like this and your certificate will look like this. You need to see that sample and आपको उस अकॉर्डिंग अपने deliverables attach करने हैं Google Forms में. So there will be total 7 certificates you need to attach, जहाँ पे ये वाला जो कोर्स है गेटिंग स्टार्टेड विद आर्टिफिशियल इंटेलिजेंस, वेरिन यू विल गेट 5 सर्टिफिकेट्स. ठीक है, ये टोटल एक कोर्स में आपको 5 सर्टिफिकेट्स मिलेंगे. एक तो आपका होगा क्रिएट अ क्रेडली अकाउंट. द नेक्स्ट 3 सर्टिफिकेट्स विल लुक लाइक इंट्रोडक्शन टू आर्टिफिशियल इंटेलिजेंस, लार्ज लैंग्वेज मॉडल बेसिक्स एंड मास्टरिंग द आर्ट ऑफ प्रॉम्प्टिंग. Your 5th certificate will be any one out of these 3 activities. So total 5 certificates. एंड दिस इज द कंसोलिडेटेड सर्टिफिकेट. तो आपको वो 5 सर्टिफिकेट्स अटैच नहीं करना है गूगल फॉर्म में, आपको ये कंसोलिडेटेड सर्टिफिकेट अटैच करना है, जहाँ पे द नेम ऑफ द स्टूडेंट एंड दे हैव सक्सेसफुली कंप्लीटेड गेटिंग स्टार्टेड विद आर्टिफिशियल इंटेलिजेंस कोर्स एंड द बैच which says getting started with artificial intelligence. So this one certificate and one digital badge of one self-learning course. The second is this certificate and the badge of that course. The third is ये वाले का सर्टिफिकेट एंड बैच. सो टोटल सेल्फ लर्निंग कोर्स के 3 सर्टिफिकेट्स एंड 3 बैचेस, एंड लास्ट में द कंसोलिडेटेड सर्टिफिकेट ऑफ योरसेल्फ which says this certificate is presented to Sri Lakshmi Nair. आपका नाम आ जाएगा फ्रॉम लर्नर टू बिल्डर बिकम एन एआई एजेंट आर्किटेक्ट. सो टोटल 4 certificates and total 3 batches we will be asking you to upload as a deliverable in the Google form. And that Google form link we will be probably circulating on your WhatsApp group by tomorrow end of the day. So please, students, those who have not started the course, the course is of maximum 6 to 7 hours. Complete the course, get the certificates, because kabhi kabhi certificate generate hone mein bhi it takes time. So today you already have 24 hours with you. So complete the course, get the certificates, get the badges, and you need to upload those certificate and badges on the Google form, which we will be circulating tomorrow. ठीक है, for the students those who have newly joined, my teammate Vaishali is putting down the link of resources and document का, जहाँ पे we have uploaded everything कि आपको कहाँ से कौन से लिंक पे क्लिक करके आपको ये सेल्फ लर्निंग मॉड्यूल कंप्लीट करना है. सेकेंड ऑफ ऑल के आपको अगर सेल्फ लर्निंग मॉड्यूल कंप्लीट हो गया है तो आपको सर्टिफिकेट कहाँ से डाउनलोड करना है, और आपका क्रेडली अकाउंट से आप अपना ये कंसोलिडेटेड सर्टिफिकेट कैसे जनरेट कर सकते हो. Every single minute detail we have uploaded on the recordings and resources document. Vaishali is putting down the link of resources and recording documents. Please copy that link and you can start doing the self-learning course if you have not done yet. Okay, the deadline that I've already mentioned is tomorrow, which is 10th of July. By end of the day, start doing the courses today itself. So for the students, those who have not joined it, those who have not started the course. Okay. The very important announcement regarding the sponsoring organization. I have been receiving many queries from the students stating that कि मैम मेरा sponsoring organization CSR box है, मेरा EduNet है. So make sure that first of all your sponsoring organization should be Open Skills Build or Shri Mahakal Education Trust, Education and Charitable Trust Rajkot. ये दोनों आपका स्पॉन्सरिंग ऑर्गेनाइजेशन होना चाहिए। जिनका भी CSR बॉक्स या एड्यूनेट या तो फिर कोई दूसरा स्पॉन्सरिंग ऑर्गेनाइजेशन आ रहा है, there was a important instructions which was circulated yesterday on your WhatsApp group stating that you can use your different Gmail ID to log in onto the platform. अगर आप वो लिंक से क्लिक करके दूसरे Gmail ID से लॉग इन करोगे तो आपका श्री महाकाल एजुकेशन ट्रस्ट एंड चैरिटेबल ट्रस्ट राजकोट स्पॉन्सरिंग ऑर्गेनाइजेशन आ जाएगा. For the students, those who have completed their learning plan, or they are in the midway to complete the learning plan, but their sponsoring organization is not Mahakal Education, you need to re-log in it again onto the platform by using the different Gmail ID. I repeat, आपका स्पॉन्सरिंग ऑर्गेनाइजेशन श्री महाकाल एजुकेशन एंड चैरिटेबल ट्रस्ट राजकोट या ओपन स्किल्स बिल्ड, ये दोनों ऑर्गेनाइजेशन में से कोई भी एक होना चाहिए. Then and then only you will be eligible to get the completion certificate of your internship. ठीक है. So basically you need to complete the self-learning courses on the platform, which are the self-learning 3 courses. After that you will be also expected to make one project. आपका कैसा प्रोजेक्ट होगा, आपको कैसे बनाना है, that we will be guiding you in your master class number 5. So it is mandatory everyone to attend master class number 5, जहां पे हम आपको बताएंगे कि आपका प्रोजेक्ट कैसे दिखेगा या आपको प्रोजेक्ट में क्या बनाना है. तो आपने सेल्फ लर्निंग मॉड्यूल कर लिया, प्लेटफॉर्म से आपने प्रोजेक्ट बना दिया. बेस्ड ऑन दिस 2 प्रीरिक्विजिट यू विल बी एलिजिबल टू गेट द कंप्लीशन सर्टिफिकेट ऑफ योर इंटर्नशिप. और वो सर्टिफिकेट आप अपने GTU में दिखा सकते हो कि मैंने 2 वीक्स का इंटर्नशिप किया CSR बॉक्स में आर्टिफिशियल इंटेलिजेंस का. सो दिस 2 आर द मैंडेटरी रिक्विजिट्स ऑफ योर इंटर्नशिप. Okay, so this call for the wrap up of the session. This is the attendance sheet which I am showing onto the screen. Please take out your mobile phones. For the students, those who have joined YouTube live, I am sharing the link of the attendance form on the WhatsApp group as well. So please, you can click on that link and fill the attendance form. And this attendance link will be valid only till 1:15. हम लोग 1:15 को जो फॉर्म है उसका एक्सेस बंद कर देंगे. So please fill the attendance as soon as possible. We'll wait for 2 minutes for everyone to just mark your attendance for today's session. Please take out your mobile phone, scan your QR code, and mark your attendance. My teammate Vaishali is also sharing the link of the attendance on the chat box. You can directly click on that chat box and you can mark your attendance for today's session. Our next session is scheduled on Saturday, which is your masterclass number 4, 11 o'clock. Don't think it is a weekend, तो आपका कोई क्लास नहीं है. Saturday आपका क्लास है 11 o'clock in the morning. So please friends, अपने टीममेट्स या तो फिर अपने कलीग्स को आप इन्फॉर्म कर सकते हैं. For the students those who have not joined today's session, please mark your attendance for today's session and please start doing the learning courses. The deadline is tomorrow. And for the students, those who have marked your attendance can leave the meeting. And if you have any doubt, you can reach out to me either on WhatsApp or maybe you can do a mail. It's 1:04 on my clock. 1:05 we will end today's session. Meanwhile, I would request everyone to please mark your attendance. If you have any doubt, you can reach out to me on WhatsApp and on mail in case of any query with regards to your learning plan, with regards to your sponsoring organization, anything, you can reach out to me. Okay. So this calls for the end of the session. Bye everyone. A very warm good afternoon to everyone. See you all, everyone, in the next masterclass on Saturday, 11 o'clock. Bye everyone. Take care.